Voilà, soyez le bienvenu. Welcome to my page, Engineer Kanene here. Today we're looking at concrete cover. Let's go direct into the lesson. We'll look at the lesson, reasons and standard, thumb rules, and finally we do an example in the calculation of balance. Okay, so let's begin. Concrete cover. What is concrete cover? Concrete cover is simply the minimum thickness of concrete between the outer surface of the reinforcement, we're talking about steel bars, and the exposed surface of the concrete member. It is measured from the concrete surface to the nearest edge of the reinforcing steel, not at its center. What do we mean by the minimum thickness of concrete between the outer surface of the reinforcement? You have a picture on your screen. This is a picture of a column. A column is simply a vertical structural member. So this column, of course, they are casting. Okay, you have this yellow, that is timber, those are shutter boards. You have your shuttering there, and you have the concrete there, then you have your steel there. So this is a reinforced concrete. So what we're talking about when we talk about concrete cover, we're talking about this distance from this bar here, reinforcement bar, to the edge of the concrete here, this outer edge here. This distance is known as concrete cover or clear cover. So what do we mean by concrete cover or clear cover? It's just that minimum distance we're talking about, that minimum thickness of concrete. So each particular structure member has got different sizes of this particular distance. So this distance is the same as this distance, same as this distance, that distance there. So now, look at this a diagram on your left side. This is a beam information. Now this is a horizontal structure member. The distance we're talking about is this clear cover here, or concrete cover. The distance from the edge of your concrete to your reinforcement bar is what we're calling clear cover. Okay? Now the distance from this edge or your outer surface of your concrete to the center of your reinforcement bar is what we call effective cover. So there's a difference between clear cover and effective cover. Then from the center of your reinforcement all the way up to the top of the outer surface of your concrete is what we are calling effective depth. So this information is significant because it's going to assist the engineer to calculate the length of this stirrup. For you to know the length of this stirrup, for one stirrup, you need to be able to put into consideration clear cover, effective cover, and effective depth. Very important. So now, there are standard sizes for this distance, this clear cover, for different structure members. Okay, so you have seen on certain sites, you see something which looks like this. This is a standard clear cover. Okay, this is concrete cover, but when it is made into these tiny blocks, it becomes what is known as cover blocks. These are simply cover blocks. They serve the same purpose as the clear cover, but in this particular case, you can actually purchase these cover blocks depending on the structure member that you're working on. So now, what are the standard minimum sizes of structure members? Minimum standards for our clear cover for different structure members. When you are designing footings or working on footings, the minimum standard is a 50 millimeters for footings. Okay, when you're working on a raft foundation, this is a foundation that looks like a slab. That is a raft foundation. The raft foundation, the top part of your reinforcement basket should have the minimum standard of the clear cover as 50 millimeters for the top part, and for the bottom mat, the clear cover should be 75 millimeters. For a strap beam, we are simply talking about a beam that has got a beam that connects two isolated footings. When two footings are too close together, you can actually link them together by a beam known as a strap beam. A strap beam is also known as a cantilever beam. So the minimum clear cover for a strap beam is 50 millimeters. For beams, the minimum is 25 millimeters. For a grade slab, this is a slab that is directly casted on the ground. Okay, it distributes the load directly to the ground. I mean, it transmits the load directly to the ground. There's a difference between transferring loads and transmitting loads. Loads are transferred from one structure member to another. For example, a load will move from a slab, it will be transferred to another structure member. It might be a beam. From a beam, it will be transferred to a column. From a column to the footing. From the footing, it is transmitted. So that is the difference between transmitting and transferring. So a beam minimum clear cover is 25 millimeters. For a grade slab, 20 millimeters. For a slab, general slab, we're talking about 15 millimeters minimum. Flat slab, 20 millimeters. For a column, for a column, a clear cover should be 40 millimeters. So when I'm purchasing or buying cover blocks for columns, I need to know that the minimum I need to have is 40 millimeters. Shear wall, 25 millimeters. Staircase, 15 millimeters. Retaining walls, 20 to 25 millimeters. Water retaining structures, 20 to 30 millimeters. And for sunshades, we're talking about 25 millimeters. These are the minimum standards. When you're casting your concrete, you must put into consideration. So now, why do we need cover blocks? Why concrete cover? First of all, you need to understand that concrete is highly alkaline. By alkaline, we simply mean that concrete is highly susceptible to cause our reinforcement bars to start rusting. So concrete cover, that distance between the outer surface and the concrete cover, enables us to protect our reinforcement bars from immediate or from eroding or corrosion. The second reason why we need cover blocks is to provide fire resistance. We all know that concrete acts as an insulating layer during a fire. So that cover block provides that fire resistance. The third point is that concrete covers ensure that there's a proper bond between the steel and the concrete. You know that adequate cover helps develop sufficient bond between the concrete and the reinforcement. If there is no cover, there will be less bond between the concrete and the reinforcement. It improves durability, protects reinforcement, it protects the reinforcement and also maintains structural strength. It improves appearance as well. Okay, so these are some of the reasons, a few reasons that we need concrete covers. Let's go direct to an example. An example we're given is that we have a column which has got the sizes of a 30 millimeters, 300 millimeters by 450 millimeters. Okay, this is a column. So the moment you hear a column, what should click in an engineer's mind is that the minimum clear cover for a column is 40 millimeters. Okay, 40 millimeters. So what data are we given? We're given that this column is a column of 300 by 450 millimeters. We know that the standard clear cover for column, the minimum is 40 millimeters. We're talking about this distance. It's 40 millimeters. The aim of this exercise is to calculate the length of this. What would be the length of our tie, okay, or our stirrup? When we are designing columns, we include ties which enables us to prevent our column from the torsion effect, okay, from torsion effect, tension, okay, in order to maintain the position of these reinforcement bars, we need to add what are known as stirrups. So the length of this stirrup considers clear cover. So here we go. What would be the length of this bar or this reinforcement bar? Okay, so we're going to put that into consideration. The tie bar, after your designing of your reinforcement bars and you decided that you're going to use 10 millimeters diameter for these stirrups. Okay, we know that the standard hook length, we have 135 degrees. Once we are bending it, when you're preparing a bar bending schedules, you know that angle there for bending your hooks there, your hook, that angle is going to be 135 degrees hook. And each standard, the length of that hook is 10 times diameter. Diameter is not the diameter of your reinforcement, which is 10 millimeters. No, it is the diameter of your reinforcement bars, your main reinforcement bars, longitudinal reinforcement bars. Okay, so the standard is 10 times D. So the length of this hook is going to be 10 times diameter. Okay, voila. So now, What are the calculations? If you notice here, is that this column has got two sides. It has got this width and this depth. So you need to know this width, which is 300 millimeters, and we need to subtract this distance here in order for us to have this standard width for our stirrup. Okay, so tie width is going to be 300 millimeters, which is this total side, 300 millimeters minus, we're subtracting it minus, we know that clear cover is 40 millimeters. So this is 40 millimeters and also 40 millimeters. So we're going to subtract 2 times 40. So this means it gives us this distance from this center here, from this edge of this bar to this edge, we have this distance, which is 220 millimeters. We do the same for the depth. Tie depth is this distance. We're going to say 450 millimeters minus 2 times the clear cover, which gives us 370 millimeters. Okay, step 2 now is to calculate the perimeter. We do the same. Since here we have 220, we add plus 370 plus 220 plus 370, we calculate the perimeter. And the perimeter is going to give us 1,180 millimeters, okay, or 1.18 meters. So this is the total length now around here. This is the perimeter of our stirrup. Not yet. We have not yet calculated the hooks now. Remember, it has to be hooked. There'll be some hooks. So now, if you go back here, we notice these hooks here. These hooks. These are the hooks we are calculating. We have calculated the perimeter of these, this length around, but we are remaining with these 2 hooks here. So of course, we're going to do 10 times D times 2. Since these are 2, there are 2 hooks there. Okay. Voila, here we go. Okay, so what will be our hook length? We have 2 hooks. So it will be 2 times 100. Why 2 times 100? Because one hook is 10 times D, which is 100. 10 times diameter. Diameter we're considering 10 times 10. Okay, 10 times 10. Okay, 10 times 10, which gives us 100 millimeters. Okay, correct that. The diameter we're getting is the diameter of the stirrup. Okay. Please correct that. 10 times 10 times D, which is 100 millimeters. 2 hooks, it will be 2 times 100, which is 200 millimeters. So we're going to add our 200 millimeters together with the total perimeter that we have in order to know the length that we're going to cut. So 1.18 plus 200 is equals to 1,380, which is 1.38. 1.38 meters is the length that we're going to be cutting, okay, for these ties or these hooks that we are, these stirrups that we are making for our column. Okay, so the cutting length, you're going to tell the guys on site to be cutting my 1.38 meters. Give me 1.38 meters, then you're going to do your spacing. If it's 50 centimeters, between the spacing, you multiply times the number, then you have the total length. This will assist you in cutting and also in purchasing. Okay, so those are some of that is how we consider clear cover when we're doing the designing of, when we are dealing with whatever we are dealing with on site. Thank you so much, and I hope you found this video educative. It was. Please like and follow. Thank you.